Hi, this is a short little mini lecture just on a couple of hormones that affect the vascular system and the blood pressure. So I'd like to introduce these hormones to you. And the catecholamines are one group, and the catecholamines is a class of drug, chemical, hormone, norepinephrine and epinephrine. And epinephrine, you should realize, is the same thing as adrenaline. Norepinephrine is the same thing as noradrenaline. So epinephrine and adrenaline are the same thing. And both norepinephrine and epinephrine will bind to all adrenergic receptors, which include the beta-1 receptors on the heart. So norepinephrine and epinephrine increase the heart rate and the force of contraction. And those two hormones, norepinephrine and epinephrine, bind to alpha receptors. Remember that those are on the vascular smooth muscle, and that causes an increase in vasoconstriction. And all of that leads to an increase in blood pressure. So those two hormones you should already be familiar with, and a couple of adrenergic receptors that we've gone through, the beta ones and the alphas. Another hormone that affects blood pressure is antidiuretic hormone, or ADH. And ADH is also known as vasopressin. I like the term ADH better than vasopressin because it sort of indicates more of its normal role. It's an antidiuretic hormone, which reduces urine output, so it conserves fluid. It's an antidiuretic. The vasopressin gets its name because at very high levels it will cause vasoconstriction, but only at abnormally high levels. So let's say increases vasoconstriction, not normally though. Vasoconstriction only at very high levels. And those occur such as the severe drop in blood pressure, severe bleeding, so a severe blood loss, you would have a severe drop in blood pressure. The baroreceptor kicks in again. That detects the drop. Another motor pathway would be to the posterior pituitary and cause the release of vasopressin. But that normally doesn't happen. Normally on a day-to-day basis, it's working as an antidiuretic hormone. But remember that it is synthesized in the hypothalamus and it is released from the posterior pituitary, and it normally targets the kidneys. And the response is increased water retention, less urine. Therefore, we're back to our relationship of increased blood volume translates into increased blood pressure. So, the catecholamines, norepinephrine and epinephrine, and antidiuretic hormone. One other hormone is atrial natriuretic peptide. It's a family of hormones. It goes by a number of different names. Atrial natriuretic peptide or peptides or atrial natriuretic hormone. It's all the same thing. There's a whole family of these peptides. And these are produced by atrial cells in the heart. When the atria are overstretched due to increased blood volume, increased venous return, the heart stretches more than normal, which isn't good. You need to, that just stresses the heart more. So the heart itself releases these peptide hormones, and they target the kidney, causing it to essentially dump water. So you decrease the blood volume, and that decreases the blood pressure. So atrial natriuretic peptide or hormone decreases blood volume and decreases the blood pressure. They are produced in the atria of the heart when overstretched due to increased blood volume. Should note that atrial natriuretic peptide is antagonistic to aldosterone and RAS. And we are going to be going through RAS in the next and final lecture of this chapter. So RAS will raise blood pressure and blood volume. Atrial natriuretic peptides lower blood volume and lower blood pressure. Okay, see you soon for the last unit on RAS.